Welcome to today's webinar, AWS Serverless and Machine Learning, Lessons Learned from a Company on the Cutting Edge. I am Jay Martin, your host for the next hour. Certainly, if you have questions throughout today's presentation, please add them to the Q&A section on the right side of your screen, and our team of experts will do their best to answer each of them before the end of the webinar. We are extremely blessed to have a trio of panelists today: Matt Bradley Berger, a Senior Business Development Manager from AWS, Matt Dahlman, the President of Creative Practice Solutions, and Ed Ip, one of the fine solutions architects at ClearScale. Before we begin, I'll let each of the panelists discuss their roles and their companies, starting with ClearScale's very own Ed Ip.
Hey, thanks, Jay, for the intro, and thanks, everyone, for joining us today. Here's a bit of information about ClearScale. So ClearScale, we're a premier consulting partner at AWS. And being a premier consulting partner puts us in an elite class because there are really only about 50 premier partners in North America and less than 100 worldwide. So that, like I said, that's pretty important to us. And we have 9 competencies that's listed here as well as on our website. We're extremely proud of having these competencies because we have to go through a rigorous review process with AWS to receive each and every one of them. And without reading through, in short, our capabilities include application modernization, big data and analytics, machine learning, artificial intelligence, Internet of Things, or IoT, migration, DevOps, cloud strategy, and managed cloud. And lastly, we have recently received the AWS 100 certified badge. Most of our staff are actually technical in nature, and we now have over 100 employees that are AWS certified.
Excellent. Matt, if you'd be so kind to tell us about Creative Practice Solutions.
Sure, no problem. We are a business consulting company, and we basically target medical professionals in the healthcare industry. We began, as the healthcare industry did, with most data and transactions happening with paper. And so our goal over the years has been to make the administrative process of the practice of medicine as easy as possible. And so with the High Tech Act and venture capitalists jumping on the bandwagon with the EMRs, EHRs, practice management systems, we have started to leverage that, and we've also found many flaws with a lot of them. And so we are trying to streamline that process and keep it so that, again, the administrative process is as streamlined and easy as possible. And so that's what we are doing with AWS and ClearScale.
Excellent. And finally, Matt, what is this AWS I keep hearing about?
Yeah, yeah. Thanks so much. Really glad to be here today. A lot of folks are probably fairly familiar with AWS providing online cloud services for a whole host of different things. We're talking, I think, specifically about things like serverless today, but a very wide array of different options, helping customers move into the cloud from being on-premise to even being able to then refactor the stuff that you've got in the cloud to make use of what we're calling fully managed services. So really helping customers from databases to compute to AI ML to, of course, serverless that we'll talk about today. So again, really, really glad to be here.
Excellent. Well, today we have a 3-pronged approach to the webinar. We'll start with AWS walking us through the general design principles of serverless computing. Then ClearScale will review some of the common scenarios utilizing this technology. And finally, Creative Practice Solutions will showcase some real-world results with serverless computing, machine learning, and some AI. So Matt, if you would please just educate us on serverless computing in AWS.
Absolutely, yeah, and near and dear to my heart. So I do a lot of the work with serverless. I've got a big team I work with worldwide, but we see a lot of interest from customers in this space specifically because serverless is really your key to getting, in a lot of ways, we're seeing business agility. There are cost savings and other sorts of stuff that tends to be very connected to it as well, but serverless fundamentally, as you'd expect, is really not having to manage a server. There are servers, of course, behind serverless. It's just what we're suggesting here is that customers now don't have to manage that, and you don't have to care about that. You don't care about operating systems. You don't care about patching things. You don't care, obviously, about things related to hardware. What you're focused on is the business logic, your code, and making sure that that is representing what you need to be doing for your customers. It really architects things like high availability into the environment by itself. So you're not having to worry about how do I set up load balancers? How do I deal with bursts of traffic? More importantly, how do I deal when I don't have traffic, where organizations typically today may have something like an EC2 instance or instances that maybe have app servers that just sit there waiting that you're paying for. In the serverless environment, really nothing's out there, and you're definitely not paying for anything until it's being consumed. And so something runs, goes away back into the ether, so to speak. But what that also means is that we have this inherent scalability and high availability architected into the platform. That's not something you have to worry about. If you need a sudden burst of thousands of concurrent transactions, this system supports that, and you're very easily able to just have that architected into the system. And so what you're doing as a business now is you can focus more on the stuff that differentiates you, as opposed to having to focus on the architectural things that in a lot of cases tend not to differentiate companies. You want your user experience and your customer experience to be superior, but you don't want to have to go and dedicate your time and resources to managing things that really aren't terribly different from customer to customer. The concept of a server, the concept of load balancing, the concept of maybe shutting down servers when you don't need them anymore. So there's a lot of different services that play into this, and we'll talk about this here in just a moment. Lambda tends to be the core of a lot of this. We also see a lot of conversations with customers leveraging containers to do more modern microservices stuff. And again, most of the customers I speak to probably have some mix of containers doing microservices, and there's a serverless component to that called Fargate, and Lambda to be able to do some more of that compute in the cloud itself. So some of the general design principles, when we look at serverless, no question, it's a different way of looking at building an application. Can you port an existing application into something that's serverless, whether it's on-premise or even in the cloud today? The answer is yes. There's generally a little bit of work required to do that. I think that's one of the reasons that we wanted to work with folks like ClearScale, because sometimes we find that customers benefit from being able to leverage from experienced consulting partners who've done a lot of these things before. What we tend to say, though, on the Amazon side here, specifically when we look at customers and their business, is that you need a real business reason to make any of these adjustments to your application itself. And so just because you can migrate an application doesn't necessarily mean that you should. There's a lot of risk associated with having to refactor and maybe rebuild or even re-platform an application itself. Sometimes that is very justified, and there's a lot of instances where we've worked with customers and they've made that decision. But what we guide customers first and foremost is it needs to be a business conversation. It isn't just let's go to the cool technology. It is I need greater agility to be able to solve more complex problems, or I need the ability to have greater access to maybe my team focusing on building business logic and customer experience instead of having to deal with the ongoing maintenance required with even virtual instances. So there's no hardware affinity. If your code, and there's probably about 7 or 8 languages that we support out of the box, but you can also bring your own sort of compiler. So any language effectively that can run on a Linux operating system can also port into here. So believe it or not, we do have a couple of customers leveraging COBOL on Lambda. So Lambda is this compute service that runs inside the cloud, but as you'll see in a second here, relates with a whole bunch of other different services that are wholly managed by AWS. So again, you're not having to worry about the scalability and up and down of these services. These are really event-driven by what goes on inside your system itself. The other interesting thing is, so these folks who are doing stuff with COBOL, COBOL itself it's not going anywhere in a lot of cases. There's a lot of business reasons that we are learning as we talk to, particularly things like insurance companies. What you do in Lambda that tends to be a whole lot more interesting than what happens in the mainframe. Not that we're going to go and bash a mainframe here. I think it's obviously dated technology, but it definitely has a lot of value in a lot of organizations today. In the Lambda world, you get this concept of concurrency. And so in a mainframe, you may be processing stuff in serial fashion overnight, that batch job that runs late at night. In the Lambda world, we're able to deal with concurrency. So you're not looking at your total number of requests. What you're doing is looking at your concurrency. How many users or how many transactions are happening instantaneously down to the hundredth of a second. So billing also is related to that as well. We're billing at very, very small increments of time and the number of invocations. And so again, if Lambdas aren't running, you're not being billed for it. The important thing to look at is these event triggers. So you'll start to hear more of these terms probably this year, because we're going to be pushing it probably a little bit more actively into the marketplace based on feedback from our customers. The idea really an event-driven architecture. And so you can use serverless to build a complete application. In fact, a lot of customers are doing that right now. Lambdas can call Lambdas, Lambdas can call on-premise solutions, Lambdas can call containers, Lambdas can interrelate with a bunch of these different services. But these services themselves, these event-driven items, they don't really get called until something calls them from the system itself. So a great example is maybe I log into a website. Well, that URL maybe has an API on it. That API then launches a Lambda function to return some information on there. Maybe Lambda does something within a queue. So maybe SQS or maybe SNS or something like that. What it maybe then does is goes into some form of data processing, dump stuff into S3 and so forth. So the idea is that your application becomes this, think of it like a bunch of Lego blocks that you're plugging together, where I don't necessarily have to care anymore about how durable and how scalable all these elements are. They are going to scale. What you need to look at now is, what do I do with a Lambda when it doesn't have any concept of state? Because Lambdas themselves are meant to be very fast, but also very cheap. They throw away, can be rerun fairly quickly. And so you need to be thinking a little bit differently architecturally when you're building and maybe migrating some of these applications, leveraging DynamoDB, for example, to store state, or leveraging step functions as a service to actually orchestrate your workflow itself. So you're spending a lot of time focusing more specifically on what the business applications and your users are doing with the application itself, rather than that overarching infrastructure and all the patching and stuff required to that. Again, behind the scenes, no question, there are servers behind this. It's just what Serverless is doing is you don't have to worry about that as the customer. That's now AWS's responsibility. So what we were saying before is there's a lot of questions we get from customers. Is this going to save me money going with Lambda? And the answer is sometimes yes, often yes, but there are definitely some workloads and some use cases where you're probably best to use something like a container, or maybe even EC2, applications that have long runtime. So if you need a specific compute task that runs longer than 15 consecutive minutes, or if I have my instances running probably solidly throughout the course of the day, the more active your application tends to be, the more you're tending to want to look at things like maybe a container or an EC2 instance. If you've got a variable workload or a very spiky workload, perfect use case for things like Lambda. And what we're hearing from customers is that the primary benefit you get from leveraging serverless, yes, there are generally cost benefits to this, but it's innovation and the ability to get stuff launched quickly. We have countless stories, and if you look at our website, aws.amazon.com/serverless, there's actually some customer examples on there as well. Customers are launching applications that otherwise would have taken months in weeks, and this happens over and over and over again. And so the ability to quickly change things, the ability to roll out new capabilities, the ability to focus your resources on stuff that really does move the needle for your business, that's what you're getting with something like serverless as that architecture behind it. Flexibility is super important as well, because these various Lambda functions, and again, Lambda is this concept of code running within the cloud itself. I can actually have multiple languages interacting in a single application, meaning I could build an application in Node and have other portions in Python and maybe even something in COBOL if I needed to, interacting with each other. And so again, what that means is if you've got developers who are more focused or better at specific languages than others, microservices and Lambda being able to support that architecture really means that those individuals are able to leverage their skills and what they're best at, rather than forcing everybody to homogenize on a specific language just because it's easier for us to be able to interact and integrate. All right, so what we're suggesting here, and again, looking at some of the examples our customers keep telling us and showing us, that serverless really provides this greatest level of agility. If you think about the concept, historically speaking, if I need to stand up an application to do something, whether it's transforming data, whether it's a web application, a serverless backend application, or something that I'm actually standing up, there's a whole bunch of stuff I would have had to do and do have to do if I'm in that architecture today in order to just get the code up and running, all the way from physical infrastructure to my storage and databases, to the orchestration layer, to the security, to the network layer around performance and load balancing, all the other stuff. We used to call it shaving the yak. It's the stuff I need to get done before I actually get to do the thing I really wanted to set out to do, which is probably run business logic that represents some form of interaction with my customers. What serverless is doing is you're just focusing on those two pieces, business logic and your API. Very important architectural thing when we look at building applications in Lambda or with serverless is that you have an API strategy around articles or microservices in your application itself. And these APIs provide the ability to both provide security, but also durability for these articles. So if something maybe needs to get re-executed because there was an error, or you need more of these spun up, because you've got this very, very fine-grained set of compute that defines your application, growing to scale based on demand isn't a matter of having to scale up app servers, these giant app servers that you're really only using a small subset of your system to be able to support user load. In this microservices serverless architecture, you just spin up more of these individual pieces, the login capability, the checkout cart capability, the data transformation capability. Just that individual piece gets scaled up, and of course it goes away when it's completed and you're not having to be billed for it. All the other stuff that you would have to do to be able to get stuff stood up is really outside that realm of your interest anymore. This is something that AWS is doing. This is one of the biggest reasons that we're seeing customers with much greater agility. Again, we're fostering innovation. I guess that's the other thing that we're seeing an awful lot with customers is that I can actually try something out on my desktop and not have to go through these arduous processes of getting access to systems and virtual instances and security teams and everything else that needs to get done. Because most organizations already have pockets of Lambda already in there. Our most common use case within our customers is through IT automation. And so it's already passed a lot of security audits. It's got free million invocations per month per account in perpetuity. So it's a great place to try out things. And of course, if something does work and someone was able to innovate something pretty easily, it's pretty easy to scale that into a fully function, get it out there into the wild sort of application itself. There's very little work that has to be done as far as refactoring those applications. So you're fostering agility, you're fostering innovation on your team. And of course, there's cost benefits to it as well. So as I was already suggesting, Lambda is really the heart of all of this stuff. This is the running of your code inside of the cloud. There's a number of different languages that we support natively out of the box. So you can bring your own runtime, which is going to be any sort of language that can run inside a Linux environment, but it actually runs your compute. And it's your code. It's not proprietary code. It's not something that you have to strong arm to fit inside of Lambda, which also means if you change your mind and you need to pull something out into a container later, or maybe, heaven forbid, move into a different cloud provider, you can just take your code. There's nothing keeping it stuck inside that architecture. Of course, the environment's probably going to need some function as a service, but we're seeing more and more vendors offer that capability today. So again, you're focusing on your compute as your method of actually paying and costing this out, and it is your code, stuff that you can just port as you needed between different environments. It also means, again, moving stuff into Lambda isn't terribly difficult, but it does, of course, depend on your business case. I was talking about the idea of event-driven architectures. Again, this term is coming up more and more lately. There's a lot of different stuff that is related to serverless or on top of just Lambda itself. So Lambda is a compute engine. Fargate is a way of serverlessly provisioning containers. So again, we see containers and Lambda conversations very, very often. Most applications, when I talk to customers, have some mix of that in there, and that's fine. I think that's a best practice in a lot of cases, depending on how your architecture and your application's been developed. But we also need to consider our data stores. And so things like S3, one could very fairly argue that S3 is the first serverless service that we came out with, because I don't really know or care which pieces of hardware store my items. I just go into my bucket and it's there. And as I scale up, I get more space. I pay for more space. As I scale down, I pay for that only space I'm using. You're paying for the value of the system itself. But there's also Aurora Serverless, and we very commonly see key value store like Amazon DynamoDB as a storage mechanism as well. There's also a whole bunch of event integrations, and there's more coming. There's probably about 30 or so different services that we integrate natively with today. But we also launched something last year called Amazon Event Bridge. And Event Bridge allows you to create third-party events to other things that are outside of the AWS ecosystem as well. So if you need to be able to build something that maybe fires in a CRM system somewhere and then launches a Lambda and other compute chains, Event Bridge is a great way to connect into that. API Gateway, we say, is probably the most common integration with Lambda. That's your front door to the house, if you think of it that way, and Lambda is the stuff inside the house. Step Functions helps with orchestration, and of course, if you've got an Alexa, she's powered by Lambda by the scenes, or behind the scenes.
Excellent.
Right, I guess we got a poll question.
Yes, thank you so much, Matt. So that brings us to our first poll question. You should see it pop up on your screen. Has your company engaged in app modernization yet? So we've got yes, no, and we are currently considering it. So we'll give just a few seconds here for some of the results to pull in, and then we'll review that and move on. All right, so of these three answers right now, we've got 10 yeses. We have 6 considering it. So definitely people are looking at app modernization right now and trying to implement that into their companies. Certainly, again, if you have any questions, you can submit those in the Q&A section on the right side of your screen at any time. Now that we have an understanding of the general design principles, Ed, if you would please walk us through the rise of serverless computing and some of the common use cases.
Sure. So serverless computing is currently the fastest growing cloud service model with an annual growth of 75%. Gartner estimates that more than 20% of global enterprises will deploy serverless computing technologies by 2020, which is a increase from just fewer than 5% last year. With a serverless model, an event triggers an application code to run. The cloud provider then dynamically allocates resources for that code. And this is very important to understand because unlike running your web application on EC2 or a VM, you want to think of it in terms of on-premise, it only runs when an event happens, and it only runs for as long as your code execution needs to take place. And once you understand that, the user stops paying once the code finishes executing. In a standard infrastructure as a service model, you often pay for always on server components, is what I just said, which is if you have a web server being hosted on an EC2 or a VM, you're constantly paying for it, even if it's 2 a.m. on a Saturday night, no one's using your application. So think of it as a utility. You're only paying for it when a light bulb is on. So when an event triggers your light bulb, your Lambda functions, you're paying when you're done with that execution. You turn off the light and you're no longer paying. And that's very important to keep in mind. This mobile backend architecture starts to describe what Matt was just talking about in terms of event-driven microservices architecture, where each of your REST API endpoints, for example, may become a Lambda function, and you would have an API gateway sitting in front of them to authenticate message transformation if necessary, and then route the request to the correct Lambda functions. So in this picture, we have a user updating their Facebook status or Twitter, what have you, that the application is calling a REST API that's passing through API gateway, triggering a Lambda functions, and looking up a list of friends for this user, and then using SNS, a simple notification service, to push notification to his or her friends that, hey, this person have made an update. And this is a very frequent use case for how these services are stitched together. Next one is real-time streaming process. The combination of Amazon Kinesis and Lambda functions is frequently used to process real-time streaming data for application activity tracking, transaction order processing, clickstream analysis, data cleansing, metrics generation, log filtering, indexing, social media analysis, and IoT device data telemetry and metering. So in this diagram, if you want to think of Kinesis on the left box with the wavy lines coming in as a limbless pipe that can handle as much real-time data as you want or need to send through it. And because Lambda functions and DynamoDBs are also both serverless and have virtually no upper limits, this architecture can scale easily with your business needs. You can send as much data as you need to pass through it, and it'll be able, and these services, the combination of these services will be able to process your data in real time. We have a customer that's actually using a very similar architecture to do just that. A customer has a SaaS application that has a bunch of services, a bunch of applications built into this service, and they want to be able to capture customer click streams to be able to alter applications responses in real time, and also capture those click streams for downstream analysis to understand which features are being used and what are not being used, so that they can focus the energy only on those things that are used and eventually sunset those that are no one's caring about, so they don't burn their engineering hours on things that will not make them money. Web application, this one, so the right side of this architecture we've seen before from the very first diagram. The magic of this diagram is really the first box on the left with S3. So every time we talk about, whenever we talk about hosting a web application, most of us, if you've been around for a while, we start automatically thinking about, I need to, host an Apache server or IIS server, which means I more than likely need to run some EC2 instances, maybe a load balancer, and some auto scaling group so that I can respond to unexpected demands. But more and more applications are now moving to client-side technologies like Angular, Bootstrap, and React, where you really don't need traditional web hosting capabilities anymore. So income AWS S3, which is simple storage service, most people think of it as just a way to, host your files, host your objects. But with the combination of S3 and Route 53, which is AWS's DNS service, you can expose this bucket as if it's a web server, because think about it, all of the rendering is happening on the client side. You now have a very simple, affordable, and highly available, and that's key, very highly available way to serve your web content without having to run EC2 instances. And again, because these are all serverless technologies, there's just no upper ceilings on how quickly you can serve your content. The last use case I have here, it's real-time file processing. So this is actually a really cool use case. We have a customer doing exactly just this. So every time a customer or a photographer, for example, uploads a photo to their website, the photo is stored in S3. The event of putting this file in S3 automatically triggers a series of Lambda functions that's managed by step functions that's not depicted in this photo, or this architecture. So there's a series of Lambda functions that would make a copy of the original image, reduce the resolution from high res to web resolution, apply watermark, then create various sizes, image sizes that the website would need to display those images. And of course, you can then, be with the cool kits and store your final images in S3 and serve that through your website. And so with this architecture, you can easily enable massively parallel processing of images, video, index files, logs, content validation, and aggregation, filter data in real time. Really, the use case around something like this is, your imagination, can go wild with this architecture.
Excellent. And so that brings us to our next poll. And that is your company utilizing any of these serverless use cases? And so we've got mobile backends, the real-time stream processing, web applications, real-time file processing, and obviously there are many other scenarios out there. And so if you are using some other serverless use case, we'd love for you to put that as well. So we'll give just a second here for answers. We'll analyze that data and then move on to hear some real world scenario from Creative Practice Solutions. All right, so looking at these results, it looks like real-time file processing is pretty common, as well as web applications and mobile backends. So as I said, real results coming up. So we are into the final leg of the presentation. Creative Practice Solutions is going to discuss how serverless computing solved some of their challenges. And so, Matt, if you would just kind of refresh us on who Creative Practice Solutions is, and the floor is yours.
Sure, thank you. Well, yes, again, we are geared towards business consulting for the healthcare industry, primarily medical professionals in private practice that are out on their own, whether it be in groups or local affiliations. And we have, over the years, tried to streamline a very complicated process. It's most people don't know what goes into actually, at the time of the doctor's visit, and then how that ends up at the insurance carrier, how the clinical information is used. There's a whole host of regulations of how a medical note should look, what you have to mention. There's liabilities of things that you have to mention, systems that you have to review. And then on top of that, there are hundreds of variables as to how you can code an event or a visit with a doctor, and then have that transmitted to an insurance company, which will, ultimately result in reimbursement. And so, that all started on paper many years ago, went from cash to paper to claim forms. Then it switched to electronic transmission. with the High Tech Act, a lot of people jumped on the bandwagon developing EHRs, practice management systems, things that could facilitate all of this and fill all of the requirements. We actually found that all of that, while good intentions, created a lot of new obstacles. It was sort of replacing a lot of the paperwork with a lot more administrative work and a lot more clicks and a lot more busy work. And so, again, our company mission is to streamline things and really to make things as practical as possible. We don't believe that medical professionals should be doing, the administrative work. And so the challenges that we have in transitioning from what is currently available into what we'd like to be available are all of the coding variables, which, that's quite a bit of data, which, we would have had to, raise money and build quite a lot of infrastructure in order just to hold that information along with the clinical information. So we were not able to do that. There are comparable systems and solutions of what we're looking to do that have had, $20 million worth of investment. And in this case, the investment is very little because all of the infrastructure exists sort of as a patchwork. And, ClearScale is able to put those things together in order to create the solution that we're looking for. With that, in order for this to work globally, there's, lots of different operating systems. There's a lack of information as far as coding. Also, that changes quite a bit. The fact that the doctors themselves don't really know coding. They're not really familiar with a lot of the rules in order to be reimbursed properly. So there's quite a bit of data and information and a lot of variables that go into that. And ultimately what we wanted is to have, a doctor basically do nothing. Have a solution where an appointment could happen, the software would listen, or an application would listen to the appointment, create the medical note and the coding from there. So there's quite a bit of different elements and solutions that can accomplish each one of those things separately. And then on top of that, there's where do you store all that information and where does it get processed, which would be a pretty huge task. One that, I'm not sure that we could manage properly. And so, this type of solution is really, it actually fits what we're looking to do. In addition to all of that, there is a huge security risk. In addition to HIPAA compliance, there's all of the cybersecurity fines on top of that. So it's sort of, we have to be extra secure, and to maintain something like that would be also quite expensive, and would require a lot of additional infrastructure and really personnel. So again, this is something that really was a good solution for us. This is the architecture diagram for our current solution. So again, I'm not really sure what most of this does, but I was able to go to ClearScale. I looked at AWS and I saw things that I knew I needed to use for my product or for my application, which was Amazon Transcribe, Amazon Comprehend, Amazon Medical Comprehend. Then it had to be secure. The data storage had to be secure. I needed to be able to access it right away, sometimes a couple times a day, other times thousands of times a day. So I needed an enormous amount of flexibility. And I was able to just communicate this to ClearScale, and they were able to implement the sort of patchwork of solutions and put everything together. And, for us, it really works because, and I think this may be true for a lot of companies that are trying to enter the sort of digital age, is that they have a level of expertise that can be translated into a software solution or an application, but they don't have the resources or the know-how to make that jump. And so this is really for us, I mean, we have a tremendous amount of knowledge and information and know-how for the actual medical notes, medical documentation, coding, how to do things properly in order to get paid properly. There's a whole host of issues with insurance, as I'm sure most people are aware of that. And that is our contribution, but the whole underside of it, and earlier Matt was showing a diagram of, the top 2 tiers was really, what the customer should be focusing on. And then the bottom 4, which is mostly the infrastructure and the serverless technology, is what is in place or what is maintained for you. So that for us really worked great. And, I wish, or it would be great if additional people could see this in action, because I think there could be a lot of, innovation and disruption in a lot of different industries, because, this makes it a potential reality instead of, the burden of building an infrastructure, hiring people that know what to do. So this, it worked pretty good for us. Again, why it was a solution for us. I'll talk a little bit about the machine learning and AI side of it. Again, there's all sorts of rules for medical coding and billing and just, clinical documentation. It's sort of, if a patient has this symptom and comes in and also has an injection or something for another symptom, how is that coded? So a lot of that is something that will be learned by the software and then implemented as, become more and more accurate as the physician treats more patients, which is good, which causes less errors. The transcribe is a key part of it because it, translates all the speech into text, and then certain keywords from that text are then analyzed for, by the AI to trigger certain codes or certain types of language. We also implemented a Spanish translation as well. So it's able to transcribe Spanish as well into, a medical note. It can translate it into English. And then again, it's also nice that we don't have to maintain any of the backend information or data, which, it's a lot of information going back and forth. And, again, it could be a couple a day, or it could be thousands a day. And, it's nice that we don't have to maintain the infrastructure or the staff for that kind of scale or the difference in scale from day to day. Oops. So again, it's a big, it really does give us quite a bit of flexibility. Over the course of the development of the application, I have, asked for different things quite a bit, and I have asked to change things quite a bit. And because of the way this is set up, it's been possible, or it hasn't been a ton of work, a lot of coding that's wasted. Basically, they've been able to transfer coding from one application to another if necessary. The cost reduction is huge. As I mentioned, we're able to do this without a $20 million investment. And especially because, as a startup, this is a sort of a side venture, but as a, going from person to person consulting, and translating the revenue from that into something of this scale, didn't really match up. So it does work, again, really great for us so that we don't have to invest too much before the product is available. The accurate translations is actually pretty key. And it's something that AWS is, constantly improving and looking at. That's also something that the AI and machine learning helps with as well, is that it learns how a doctor or a medical professional says a certain word or a certain symptom. But that obviously is pretty key in order to get an accurate medical note. So that is very important. The HIPAA compliance, again, is very important, and but it wasn't too, surprisingly not very difficult to implement and maintain. Again, not something I would be able to do on a digital level. And then the one thing that was another hurdle for us was, we have this fantastic application. Now, how do we translate that or interface that with all of the existing solutions that are already out there? I mean, there are scores of practice management systems, EHRs. And so we did implement lots of different export options in order to make that possible. And we're not trying to be all things to all people. We're doing a very specific function. And so we do need to be able to export that information into another practice management system in order, or a clearinghouse to send it out to the insurance carriers, or just for simple, data analytics, which is something that we're looking at as well, which is actually going to be a nice sort of byproduct of this, is that we will have all sorts of data that we don't have to store and maintain. And we can leverage that data for certain outcomes, which would be an additional stream of revenue. So all of this is, only made possible by ClearScale and AWS at this point.
Appreciate it. Thank you so much, Matt. And that brings us to our final poll question. Which of these AWS serverless services are you using today? Step functions, Lambda, DynamoDB, S3, Kinesis, API Gateway. So we'll give it just a second here for people to throw in some answers, and then we'll toss it back to Ed. All right, I'm seeing a few Lambda, a few S3. Wow, a nice blend, it seems like, from all the attendees today, where we've got some answers in every single one of these categories. So Lambda and S3 are certainly the most popular, but good to see so much use out of all the different areas. Now, Ed, before we move on, I did want to have you kind of go over the various offerings that ClearScale has on the serverless side as well as the machine learning side.
Yeah, absolutely. One thing I want to point out is that, as I mentioned at the very top of this webinar, is ClearScale being a premier consulting partner with AWS, we have access to a lot of funding opportunities to help you offset the cost of, either training or proof of concept of doing project work. And we try to outline some of those, but, we try to find opportunities where we can, help you save a little bit of money. So in terms of serverless and serverless opportunities, first one here on the left is Serverless Immersion Day. So what is an Immersion Day? It is through the combination of lectures and hands-on labs where we can help your team, get the hands dirty, so to speak, so they can start thinking about your own use cases and how your use cases would fit into the technologies that are available today. And there's no cost to you, so that's absolutely a great opportunity for your team to learn something new. Serverless assessment takes about 2 days. Again, it's no cost to you. This is for us to come hang out with you more over Zoom probably, where we try to understand your business requirements as well as where you are as an organization, as well as your tech stack and your applications, to figure out how do we get you there? How do we what's the plan? What's the roadmap looks like to get you to become serverless? How do we modernize your application? The third one there is serverless proof of concept. Takes 8 to 10 weeks. Really, the numbers there, it would depend on the complexity of this proof of concept, and we can generally get up to about 15% off the total project cost through funding program. And again, we try to understand your requirements. If you have already an application, let's say a monolith that you're trying to chop up into microservices or serverless, we would do that. We'll refactor your code. A small portion of it that we designate as the proof of concept together, and deploy that into AWS, so you can start seeing how this will work, as well as help you with a roadmap for the next phase of your application becoming serverless. And then the last one there is serverless refactoring, 8+ weeks, similar to the proof of concept. And this the refactoring phase, at this point, we are going to pretty much refactor an entire application, whatever that may be, from what is now to serverless, using all the technologies that we have talked about today, however it fits. And then we also have some AI ML offerings. AI ML workshop is similar to the serverless immersion day, where it's a combination of lectures and labs, as well as it can also be that we talk through your requirements and figured out, again, similar to serverless, your roadmap to start using AI ML, and what does that look like, and what kind of technologies will be involved, or is it even possible? We do have customers from time to time to say, hey, I want to do this, using AI ML, and it's just not enough information for us to go on to build something that's meaningful. So it's a valuable opportunity. Hope everyone takes advantage of it. And then the last one here is AI ML Quick Start. It's a combination of education and assessment. So it's combining everything we kind of talked about between immersion days, workshop, to understand all of your requirements, give you a roadmap, and shows you, even an architecture that you can walk away from and say, if we were to walk away now, here's what you need to implement. So again, it's another valuable service that we offer.
Excellent. I appreciate that, Ed. And so now it brings us to our questions piece of the webinar. Certainly, if you have any additional questions, add them to the Q&A section. But I have had a couple of that have rolled in. So Matt Dahlman, starting with you. How much did you know or understand about serverless computing before exploring your solution with ClearScale?
I knew that it was possible, and I knew it was available. I had taken an MIT course called Digital Transformation, and that sort of just was meant to be an introduction of new technologies available for businesses that either want to, sort of evolve into the next generation, or not, or start new companies. And so I knew it was available, and I knew that certain things were possible. And basically, I was able to look at the AWS menu and see, I had a very basic understanding of the different solutions that I needed. But I certainly didn't understand how complicated it would turn out to be, as we saw in the architecture diagram. But that was really it. And I mean, I was able to articulate, I understand I need this solution for this. I understand I need a serverless solution for this part of it. And but I need somebody to put all that together. And so that's really that was my jumping off point. Perfect.
And then to the other Matt, is serverless less expensive than Amazon EC2?
Yeah, that's always a good question. I guess the answer is it depends, and I'm not trying to dodge the question necessarily. A lot of what ends up being the really big depending factor on your cost is really what your workload is. Is it a steady state workload where you're spending time over the course of 24 hours, for example, with your EC2 instances fairly heavily used? I think when we look at our stats, so Amazon, we don't know what you're doing in your EC2 instances, but we do know what the hardware behind is ultimately doing. And so what we typically look at when we see is that most EC2 instances, if you aggregate it over 24 hours, they're actually just idle sitting there. So I think if you're in a situation where you're paying for idle compute or an app server that's just waiting for something to happen, you tend to be saving a lot of money moving into something like serverless. If it's a steady state workload where it's always active and running fairly consistently throughout the course of the day, EC2 actually might end up being a cheaper option in some cases. I'd say it's more of as we look at more modern workloads, it's more rare that becomes the scenario. Serverless does tend to be cheaper. But that is a consideration. I think the other thing to consider is that there is a concurrency level that you would need to work with in the serverless realm versus the EC2 world, where Lambdas, you can run thousands of Lambdas pretty much instantaneously if you needed to. But one of the things we coach folks when they begin to build their application is, do you need that level of throughput? Just because the system can support it doesn't necessarily mean that your business case requires that. There are ways that you can sort of architect that pretty easily, actually, just to make sure that you're being a bit more contained. So most of the time, the answer is yes. It is cheaper in serverless versus EC2, but of course, it always depends on the workload.
Excellent. And then Ed, I thought you had mentioned previously that there's a couple of different ways to kind of test things out and just kind of get your feet wet.
Yeah, absolutely. So the cheapest way, if you want to game the system, sorry, Matt, is to create a new. When you create a new account, you're in free tier for the first year, and the first million calls every month and up to about 400,000 gigabit seconds per month is free. So that's a lot of time for you to play around. And if you don't want to do that, and if you look at the Lambda pricing, it's 20 cents per million calls with there's some gigabit second pricing as well, but you're really not talking about a lot of money if you just want to play around, because you're not going to have a million calls when you're just playing around with what it can and cannot do. And one interesting fact, and I'm absolutely not plugging this website, but I think a lot of folks on this call may be aware of them. A company called Cloud Guru. They're online training. If you wanted to get an AWS cert, for example, you likely would go watch their videos. Their owner of the company, Ryan, often tells people that when his company first started, his website first started, they did not pay a bill for a long time because his entire training website is built on top of Lambda and serverless. So that's pretty cool use case there. Not to tell you to game the system, but there's absolutely a lot of opportunity to play around.
Excellent.
No, that's a good point. I don't even think it's a bad thing, by the way. Just we've got a lot of different customers. Actually, if we look at maybe the average customer probably doesn't pay for Lambda overall because you're well within that free tier. And actually, for us, that's good because, I mean, we're giving value to the customers. It's not terribly expensive on the back end for us to manage this stuff. And then I think there is an opportunity for those to actually grow. So yeah, no, definitely we encourage folks to use the free tier as much as possible.
Awesome. And then is there any case study of AWS DevOps or code pipeline working with serverless? And from our perspective at ClearScale, we have a huge catalog of case studies on our website. I'll be sure to send that over to you. But Matt, if you have any particular reference to that piece, is there any case study of AWS DevOps or code pipeline working with serverless?
Yeah, that's a pretty common one too. We've got a few on our external website. Actually, a great example. So T-Mobile ended up building quite a sophisticated infrastructure for their serverless development teams, something they call Jazz. So it's actually an open source platform, Jazz, like the music. What they do is they leverage a lot of those individual pieces like code pipeline and code build with serverless to actually facilitate and build an environment for their users. So it's both a part of their architecture, but also a way that they provision those pieces for the developers to actually work in this environment. But yeah, aws.amazon.com/serverless. There's lots of really good examples, and DevOps is a pretty common one for us.
Perfect. All right. Well, I think we are starting to get up against the clock at this point. But should you have any more specific questions or you'd like to schedule a free consultation with a ClearScale solution architect, You can certainly reach out to sales@clearscale.net, or you have all the contact information here. I absolutely want to thank AWS and Creative Practice Solutions for participating today. And finally, please be on the lookout for some of our upcoming webinars. We have Get Comfortable with Container Technology on July 22nd, and then Best Practices for Managing and Analyzing Your Data with AWS. That one looks to be like it's going to be on August 4th. Those emails are going to be going out soon, and we would love to have you attend. This webinar was recorded, and certainly if you've attended today, you can access that recording as soon as it is published. Otherwise, we hope that this has been informative and educational, and certainly, again, if you have any questions, please do reach out at sales@clearscale.net. Otherwise, have a great rest of your week, and we look forward to discussing serverless computing with you soon. Thank you, everybody.
Thank you.